Hi, this is the last section of my A-Level Computer Science NEA testing video. This will include sections 3 and 4, which is data storage, testing, and outputs. Section 3 is a very short testing section. It just includes 2 points, 3.1 and 3.2, which can be tested together. They encompass the storage of data in the database and the general functionality of the database. So we run the system, and we have a vehicle enter. We can see that that's popped up in the car park there with no exit time if we have the exit time on it there. Now if we close that down, and we can see and check that that record's been amended to the database by checking the Microsoft Access file. Where if we go into the car park table, we can see that record has been correctly added there. Now if we close that back down and go back to the program, the car park is refreshed every time the application is run for testing purposes. But if we run this again, that car can enter there as such and leave. Now with this tab at the bottom, we can select a variety of options. The first will be the students. This will simply display all the data in the students table. I've already added this data to allow us to test the system. The same for vehicles. We can run that query. These contain all the vehicles that are registered with the college. If we go for select all, that will look at the car park again. So the car park currently contains one vehicle. If we go for select all, that will run an inner join between that and the student and vehicle database to provide a comprehensive overview of who that is, as shown there. And if we close the database, that closes the database and we can end the application. Moving on to section 4, input, output, and database querying. 4.1 is the test data and testing the first name query box input validation with 3 test pieces of test data, a sort of general piece, an erroneous piece, and a extreme piece of data. So if we run this now, for the purposes of this, I will add this number plate to the car park. Now these query boxes are cannot be accessed unless the user is on the select all. If we go to here, we can test the first piece, which is the name as shown there in first name. If we run that, there are no issues. That's been returned there, but nothing's had to be filtered. If we run the second item, which is a collection of integers, and run that, the record is removed, no error is returned. It's simply just processed that, has not managed to find anything associated with that. And the last one is an extra long name. So we put in a long string of characters. It reaches a limit, and yet again no value is returned and no errors have been returned either. If we delete that, and if we run that again, we can see that the car park is still there. Next, 4.2 is querying with the last name. Similar process. If we start with a normal name, put that in there, the query is returned. If we now test that with integers, nothing's returned, and an extra long piece of data, nothing's returned. Now on to 4.4, which is the same thing, input validation for the registration query box, starting with a standard number plate. that's a 1. There we are. And that's returned perfectly. If we add, say, a Boolean value in there, nothing's returned. I can test that again with integers as well. Nothing's returned. And finally, with an extra long, run that. Note that if one of these is lowercase, it's still returned. Now on to student ID, which is very similar. If we run this, let me add that to the database. Okay, perfect. Now, if we test with student ID, the first criteria is a standard integer. Which if we put that in, returns no value, but no errors are presented. If we now put a string in, note that student ID is an integer field, i.e. test. It returns student ID, not integer, and asks you to enter it again. If we add an extra long integer as an extreme piece of data, the field has a max capacity and no error is returned. Now on to testing the queries and the data they return. For this, we'll need to fill up the car park. So if we run this again, okay, let me add these. So we should now, if we look at the car park, we have a very full car park of number plates. So the first thing to note is that when you click select all, an inner join is performed and the data associated with these number plates is shown. Now the first thing we're going to test is the student name query. So the first test there is with a normal first name. If we go back to there and we take a look at everything there. Normal first name, let's go for Stuart. Run that and that pops up there. The next test is with a name not in the database. Back. And think of a name that is not in this database. We'll go for Ethan. That is not there. Another thing to note is that say, oh, I put that in the wrong one. Another thing to note is that say a name such as Daniel, which appears twice in the database, is entered, both records are returned. Next is test 4.6, which is the same but for the last name. So if we run that, the last name, we can see that if we put Cowlin, 1 is returned. If we put a name that is not in the database, if we go for Hodgson and run that, no records are returned. But notably, if we go back to the example used before with Daniel, we can run that and 2 examples are returned. If we put in a surname, both queries are run and just 1 value is returned. Next is test 4.7, which is the query with student ID. So we go back here and we look at the database as a whole. We can see that if we query number 4, that value is returned. If we query number 40, which does not exist, nothing is returned. Next is the test with car registration, test 4.8. Both in and not in the database. If we run this, we can see that if we put in C74 YUF, that value is returned. If we put in a number plate that is not in the database, no value is returned. Next is test 4.9, which was briefly shown earlier. The first is with first name and last name, as shown here. We can filter by Daniel and then by last name. But also we can do by student ID and registration. Any of the fields can be queried together. Next is test 5.0, which is the invalid parking feature of the database. So if we look here, we've got all these cars in the car park, many of which match up with records in the database. If we run this, so if we look here, invalid cars will be those which are in the car park but do not exist in the student database. So if we click on the invalid registrations and run that, none appear. So the system has matched every record in the car park to a student record. If we run this, which does incorrectly provide the number plate, but that is not relevant here, and go back to car park, you can see that's been amended there. Now if we look in invalid registrations, there is a value there. So any values which are not associated with a record are added to that database, to that table. Next is the car park count check. So if we restart this, that's test 5.1. If we restart this, you can see up here is the car park count. So if we load the car park table up, and this car drives in, you can see the car park count is set to 1, and this will simply increment every time a car enters the car park. If a car was deemed to exit the car park, you can see the count decreases and increases as such. And back to 0. That is the end of this testing section, which also concludes the testing of my project as a whole.